So they're making a one-on-one comparison between pup suckling and consumption of cocaine, which could be wrong. And let's move on to the experimental design itself of this particular study. So if you remember how they tested, how they knew what the subjects preferred, they actually they asked the subject to rate the images and the sound. So the study, in actuality, it's a test for preference and not beauty. It has been criticized because the interpretation of instructions varies by individual, and there was no control for that. And usually, what people do is they kind of hide their actual experiment in like random tasks, so that the subjects can't figure out what they're being tested for. But in this case, it was so clear that they were looking for the creative brain area, which could lead to biased results. And also, because they are comparing samples from different people who responded to different images in different ways, they are making comparisons across different stimuli, activation caused by different stimuli. There's no control for that. And of course, when they look at images in a giant magnet, it has a different feel than when they see it outside of the magnet. So does their preference carry on to the actual imaging? That's something that has been raised by other people. And so after this paper was published, it was actually found that this area that they claim to be the beauty center, it actually is a part of a larger network of brain regions that subserve all value judgments. So for example, MOFC was found to be activated in some of the researches that look at self-evaluation or personal preferences, which does make a lot of sense. So now the question is beauty a universal principle? Can we have like a general elements that indicate that something is beautiful or not? From these studies, it seems like, at least for facial beauty, there are elements that are cross-cultural. This study shows that facial beauty is age-independent, so people who are young or old will think that a beautiful face is a beautiful face. And even in infants, they looked at attractive faces more longer than unattractive ones. And for infants, they're kind of automatically controlled for cultural or social teachings. So it seems like there might be a general standard for attractive face, and it is the fact that beauty plays a role in mate selection makes it a biological factor, or it seems. And a lot of the sociology studies show how people tend to associate non-physical aspects of a person with their facial attractiveness, such as intelligence, honesty, leadership, and etc. One of the people, so there are big names who support this view, and they're trying to find out what these elements of beauties are, and that includes Eric Kandel, Semarzeki, and also this guy, Ramachandran. He is the director of the Brain and Cognitive Research Center in UCSD. And in 1999, he came out with 8 laws of artistic experience. These include pick shift principles, perceptual grouping, isolation, contrast extraction, symmetry, blah, blah, blah. And let me go through them one by one. And his goal, his goal for making these laws of artistic experience is to provide a framework for understanding different aspects of visual art, aesthetics, and design. But it has been criticized by a lot of people. Anyways, so what is peak shift principle? It is the phenomenon that we see in a lot of animals and also in humans. So when, for example, when a rat is trained to select this rectangle by giving him rewards whenever he selects this, when exposed to a choice between the rectangle that it was trained in and a more longer exaggerated rectangle, the rat will always choose the exaggerated form. So that's what the pick shift principle is. And this is also seen not only in laboratory situation, but also in nature. So one of the instinct behaviors of seagull chicks is to peck on the red part of the beak of his parents to can encourage regurgitation so that they can feed on it. And this also works for a stick with a red spot on it. When you present this to the seagull chick, it'll like peck on the red spot. When given the choice between 1 red spot and 3 red spots, guess what happens? They go crazy over this. So Ramachandran is using this principle to explain some of the characteristics that we see in art. He claims that there is a peak shift of female sexuality across culture, whether it be a peak shift for fertility expression, for soft, baby-like white powdery skin of females, or a posture that can only be managed by a female figure. He also indicates that this is a principle. This is the principle behind caricatures. So you would probably recognize better who these people are than looking at this image. And this image has been altered slightly to exaggerate some of their facial characteristic facial features. And it's very subtle, but yeah, I think I can recognize these guys better. And he makes quite a jump and tries to convince people that when people look at the reason why people enjoy looking at Van Gogh or Monet, Picasso or Matisse is because these artists tap into some aspect of form perception. Another important element that Ramachandra raises is perceptual grouping, the fact that we have a tendency to group independent elements together to make a closed form. So that leads to our preference for proximity, similarity, closure. We tend to think these two belong to each other rather than these two. And continuity, we see this as one line and this as one line, not like that. And this actually has a lot of similarity with Gestalt's principle of design, where different elements, we tend to group different elements together to make a sensible form. And this is a very famous example using this principle. And once you find the Dalmatian in this figure, you can never undo it. Whenever you see this figure again, you will just immediately go for the Dalmatian. And he says this is because of this feature binding, which causes a reward in our circuit, and blah, blah, blah. But I don't know. So did you find the Dalmatian here? Yeah.
Where is it? Is it? Oh, I see it now.
Yeah, that's his ear and legs. And another element that he says is important in aesthetics is the contrast, whether it be contrast between colors, contrast in texture, or contrast in conception. He also emphasizes the importance of symmetry. He says that most biological important objects, such as predator, prey, or mate, are symmetrical, thus attention-grabbing. So anything that is asymmetrical, we want to fix it and makes us uncomfortable. So like you have the tendency to fix your eyeglasses. That's an example that he gave. And he says, according to him, generic viewpoint is where our visual system dislikes unusual vantage points. So for example, if we look at this figure, we assume that it is an overlap of 2 squares, and we never imagine it to be like this. Same thing happens. We tend to, we can derive a cube easily from this drawing, but not from this, because it is very unlikely for us to encounter a cube that has, at a perspective that is that has the diagonal points at the same viewpoint, at the same vantage point, and that's the reason why we prefer this composition of landscape over this one, because how many times in nature do you encounter this unnatural coincidence? Use of metaphor is important in us appreciating art because it acts as a mental tunnel between two concepts that appear grossly dissimilar on the surface but instead share a deeper connection, and we feel pleasure in finding that out and figuring that, unsolving that puzzle that artists give us. Oops. So this is an example from Frida Kahlo using a lot of different symbols in her painting, not to mention, not the least, the symbols used in religious paintings, and this is also found in other cultures as well. And also not only visual art, but also literatures. So you can see Shakespeare using the sun as a metaphor for Juliet. So Ramachandran's way of describing aesthetics experience is very utilitarian. He answers the question why art objects are beautiful and tries to come up with a practical definition and purpose for beauty, which is a biological purpose for beauty. However, he has been largely criticized because he doesn't make the distinction between sympathy, elation, memory, versus beauty, and he tends to use these two terms interchangeably. And also, he has a tendency to universalize his own subjective convictions, and that's something that you find in a lot of his research. And also, he has a very outdated understanding of art. He thinks that art is supposed to carry the essence of beauty. And as we move on to modern art and postmodern art, we know that that is not true anymore. Well, let's move on to Marge Livingstone's work. So in her book, she analyzes artworks to reveal important information about how we see. She examines different strategies that are used by artists in their work in the context of mechanism of vision. And she gives a lot of examples of illusions and how that is incorporated in like classical paintings. So before moving into that, let me just briefly give you an overview about the visual pathway. So once the light enters our eye, it gets encoded into electrical signals by cells in the retina. So I'm sure you already know this, but there are two classes of cells in photoreceptors. There are rods, which are colorblind. They get saturated very easily, so they're only used in dim light. There are cone cells, which have three different types of cells that respond to different wavelengths of light. So they're color selective, and these cells are what we usually use to view things in normal daylight. And the electrical signals that is elicited by photons hitting these individual cells, they get collected by these large ganglion cells. And in the process, they go through these intermediate cells that are either excitatory or inhibitory. And the ganglion cells, there are largely two types of cells, one that responds to light and one that responds to dark. Let's see. I think it'll be better to understand if I just showed you this video at this point. So this video that I'm about to show you is an actual recording from Hewell and Wiesel's research. They were the first ones to understand how visual pathways were organized. And what you're going to see is the actual projection that is that is placed in front of an anesthetized cat, and you will hear like spikes, and that is the neuronal spikes that they're recording from in the cat, in the LGN. So let me just play that for you. So the first is on center. So they're finding the receptive field, and you can see that they already drew out which part of the visual field this particular cell is responding to. So it's around, you can hear the spikes when there is a light stimulus overlapping that center. And this is opposite case, the off-center LGN cell. So again, they're mapping out the receptive field. And you can hear cells crackling when the light goes off. Right? And it is a center surround cell, so it responds to the relative difference between the surround and the center. Yeah. Okay. Stop. Sorry about that. Okay, so the signals that are collected from the retinal ganglion cells, they get projected to a midbrain level of organization center called the thalamus. And this is where the segregation between the two visual field happens. And also it is organized in terms of the type of ganglion cells. So the smaller ganglion cells, which are populating the center of your visual field, passes through this parvocellular layer, and the large ganglion cells that are around the periphery of your vision, it gets collected in this magnocellular layer. The thalamus then projects to finally the cortex, and upon reaching the cortex, and this is the primary visual cortex, the signals gets converged to produce more complicated information about what you see. So at V1, stuff like motion detection or spatial map, pattern recognition, or direction of motion happens. And as it gets further into higher cortical areas, the signal gets more and more complicated to a point where it's finally object recognition and motion detection happens. But all in all, what I want to emphasize at this point is the fact that there is a segregation of function as you move along each stage of the visual pathway. So in early visual pathway, there is an extraction of very simple elements like light and dark. In the middle visual pathway, there is segregation and grouping of elements to form coherency. And in the late visual pathways, there is recognition of meanings and recognition of forms. And this is what I meant at the beginning of the lecture when I said there is a dorsal stream and a ventral stream. So the dorsal stream, which is responsible for the wear information, is colorblind. It is very fast. It has low acuity, and it is sensitive to high contrast. So it's where the periphery vision goes. And the WAT pathway, that's the part that is color selective. It is relatively slow. It has very high acuity, and it is sensitive to low contrast. And we don't need a lot of color information in order to detect form and to recognize figures. And Picasso knew this very well. And he discarded all the color information and painted the entire scene just blue to emphasize the emotional aspect of this painting. And this is a painting by Matisse where he understood that each color had different illuminance, and he used that relative level of illuminance in different colors to paint this picture, which seems, ordinary at this black and white scale, but with color you can see how unusual his selection of colors were. Similar thing happened with Matisse's portrait painted by his friend, and you can see the treatment of shadows, how it uses some unusual hues, but at the right luminancy. The relationship between luminancy and color and the physical aspect of how light works wasn't understood until the Renaissance. So during the medieval times, blue was colored as a blue block of paint. They weren't very interested, or the way they expressed values, and especially very saturated color like blue and red, was very flat. It wasn't realistic. And to solve that, it took someone like Leonardo. So his solution was to select colors that were in the mid-range of its luminancy to maximize the range that he can express values in. And he also wrote a note to his fellow painters saying that, remember, painter, to dress your figure in light colors, darker colors will make lesser relief and be little apparent from a distance. This is because the shadows of all things are dark, and if you make a garment dark, there will be little variety between the light and darks, while the light colors, there still will be greater variety. And after Leonardo came up with his solution of maximizing the variance in luminancy using mid-range colors, Michelangelo came up with another solution of his own by mixing in white and black in colors to express the full range of luminancies. And because of that, you can see in a lot of Michelangelo's paintings, there is this metallic sheen to it. That's because he added white and black to maximize the luminancy that he could express in all the colors. And while we are talking about colors, there's one point that I want to make. In some instances, there are colors that are same in luminancy but are opposite in their color scale. And this causes this confusion between the colorblind wear system and the color-specific what system, thus creating this illusionary motion. And this has been recognized by artists and has been exploited not only in op art, which specifically uses visual illusions, but also in impressionist paintings, such as that of Monet. Here he is using these equiluminate colors to express the gentle flotations and almost the ambiguity of the ice floating on the lake. This is another example from Monet, and you can see how he uses contrasting colors but with equal luminancy to create the shimmering effect of the lake. And actually this color scheme was replicated by a psychologist in Japan to create this rather famous illusion. And his name is Akiyoshi Kitaoka. And Monet was a master in equiluminance colors, and here he's using that aspect, that property of colors to make this sun almost undulating. So it has a very striking feel to it when you actually stand in front of this painting. There's this bright red spot on top of the very grayish, blue-grayish background, and it's very striking. And it almost seems like it's, going like this. And this effect disappears, and you can see how the sun perfectly blends in with the background without the hue information. Mondrian was another person who liked to use ecoluminance colors to make illusions of motions. So in this painting called Broadway Boogie Oogie, he's using colors that are ecoluminance. So the gray and the yellow are ecoluminant, the red and the blue are ecoluminant, and overall it makes the painting kind of busy, and it has the illusion of a busy street. Another important aspect that Marge brings up is the fact, because of the fact that our visual system is comprised of center-surround inputs, we are very sensitive to edges, and we are not that sensitive to the solid colors or the solid values. So this is an example of an illusion kind of playing on this fact, and you find that this rectangle is slightly darker than this, but in fact, that is an illusion caused by a sharp gradient that was created in the middle. So they're actually the same value, it's just that we are ignoring all the information on the outside, but are only concentrating on the edge, which is in the middle. And the same principle is behind this famous illusion of the grayscale shadow illusion. So A and B are actually the same value of gray. It's only that the fact that A is surrounded by lighter colors and B is surrounded by darker colors, it seems like they have different values. So B seems to be more lighter than it actually is. And this is a pretty fun example of using this principle. That's pretty fun, right? And the reason why you see dark spots in the middle of these light circles, light intersections, is because we have less inhibitory signals coming in when you are focused, when the neuron is detecting this spot, versus here there is more inhibition and thus doesn't have that effect. So it gets released and you see this dark spot. And this principle has been widely used by artists. Artists understood the fact that when you look at something in the dark, you would have a different experience depending on what the surrounding is. So this is an example that Marge has in her book. So she took a photograph of her son in the same composition as this painting. And this is what the real illuminance would look like. At the center of the light is where the most where it is most light, and it kind of disperses and loses its intensity as it as it moves away from the center of the light. But in actuality, what we see with our eyes, because of the surround effects, is more similar to this. So same thing happens with color as well. So we have color opponency because our cells, our cones are organized so that when they are excited by red, for instance, the green is inhibited. When they're excited by green, the red is inhibited. And when they're excited by blue, yellow is inhibited, and vice versa. I'll skip that one. And so this is an example from Monet where he uses this color opponency. And this is something that we can all see in our daily life, and probably we can see by looking at outside the window now. And in the clear daylight, when there is direct sunlight shining on the snow, because the sunlight it tends to be more towards the yellow scale, the shadow would look more bluish in tone. And Monet is kind of experimenting that aspect by placing blue paint around the shadow and yellow paint at the edge. This is a nice illusion of using color opponency. So if you stare at the white circle, at the white spot for 10 seconds or so, and try not to move your eyes around, because the cone cells are kind of slow to recover and they get fatigued very easily, you would get an after image of a actual American flag, because the colors that used to be inhibited from the previous from the previous image suddenly get released, and this is what you see, like this burst of color. Last thing, okay. So another thing, and this is where the cover of this book comes from, is spatial resolution. The fact that you have the sharpest focus at the center, and as you go through to your periphery visual field, it gets very coarse very quickly. And she uses this principle to explain one of the biggest mystery behind Mona Lisa's mysterious smile. So it was noted by a lot of people that sometimes she would look like she would be smiling, sometimes she would look like she's mad, and her emotion was kind of hidden in veil. Some people thought that it's because she's missing her eyebrows, but Marge's explanation has to do with spatial resolution. So when we are looking at her face with our peripheral vision, this is close to how we are seeing it. And because of the way the shadows are treated around her face, it creates a more smiley face. But with higher acuity, with higher resolution, as if we are focusing our attention, visual attention at her mouth, we see that effect disappears. So you see that when you're actually looking at her mouth, when you're focusing at her mouth, she doesn't seem like she's smiling anymore. But if you look at her eyes or like around her hair, she suddenly has this giant smile on her face. And that same principle is at work when comparing these two pictures. So she compares Monet's very rough paint strokes with Poussin's very realistic, detailed, fine paintbrush strokes, to describe how this is close to the actual way we perceive motion in our peripheries. So this has an illusion of activeness, although there's a lot going on in this scene, it doesn't look as active, or it seems very still because everything is in focus. And we have a tendency to draw our focus to look at people in their faces, and we easily forget how little information that we perceive from the surroundings. And